Hey guys, welcome to my video on writing in factored form. So in this video, I'm going to cover how to write polynomial equations in factored form given a graph. Okay, so let's begin. So in this exercise, I have given you a graph and I'm asking for you to write it in factored form because once you have it in factored form, you can turn it then into a polynomial standard form. Okay, so let's begin. So what we first want to do is identify the following. We want to identify the end behavior. All right, so my end behavior, I'm going to write in purple. So my end behavior is here and here. So we want to analyze that. So I know this has to have an odd degree, and I know it has to be followed by a positive leading coefficient. Okay. All right, so next we want to analyze our zeros. Okay, so I know my zeros are here, here, and here. So I know my zeros are x equals -1, x equals +3, and x equals +4. All right, not only do I have to analyze my zeros, I also have to analyze the multiplicities. Okay, so just to recap, a multiplicity is what happens at the x-axis. If it goes through the x-axis, that means it either has a multiplicity of 1 or any odd number. Okay, if it curves through like a x cubic, like how it curves through the x-axis, that means it has a multiplicity of 3 or more. All right, so the bigger the curve, I guess, it is the bigger the multiplicity. Okay, so let's go back. So it looks like it doesn't curve. It just goes through the x-axis. Once here, and once here. So that means there are no multiplicities, or I can say that the multiplicity here is 1 for all of these zeros. Okay? All right, so the next thing I have to analyze is my y-intercept. So my y-intercept here is this point. So y-intercept is 12. Okay, so that all the information you need. Now you're ready to write it out in factored form. All right, so this is a little bit easy to see because you know your zeros and multiplicity is just 1, right? So you can assume that p of x is equal to, in factored form, because these are the zeros, then my factored form is x plus 1, and then x plus, -3 for the 0 to be x equals 3, and then x minus 4, right? So you would assume this is true when you multiply it all out. It should give you a y-intercept of +12, right? But sometimes that can't be the case, so you have to double check. So we must, before you finalize, we must find the value of k for which it is true and checks out with the y-intercept. Okay, and you're going to see this value of k is very beneficial when you're writing in factored form. Okay, so very simple. I am going to plug in what I know. I know that in order for me to get my y-intercept to be 12, I must plug zeros for x's. All right, so that means that this is going to be 0 plus 1, 0 minus 3, and then 0 minus 4. Okay, so 0 plus 1 is 1, 0 minus 3 is -3, and 0 minus 4 is -4. Okay, altogether, when I multiply this, this should come out to be +12. All right, and if that's the case, then what happens is that means that when you multiplied when you plugged in a 0 for x, you got a +12. So this is 12k on the right side, and on the left side, that is 12, which is your y-intercept. And when you solve for k is equivalent to 1. Okay, so the importance of that is the fact that you can leave it as x plus 1 times x minus 3 times x minus 4. That's the factored form of this graph that checks out on all bases. This means that it's going to have an odd degree, a positive leading coefficient because k is +1, Zeros that crosses at -1, +3 at +4 with a multiplicity of 1. And when you put zeros here, here, and here for the x's, you will get a y-intercept of 12. All right, so this is the completely factored form. Okay, so that's my example. Here's my other example. Okay, so again, let's analyze the end behavior. All right, so the end behavior here is here and here. Okay, and so my end behavior is has to still be odd, but now with a negative leading coefficient. So just because it has a negative leading coefficient doesn't mean that you're just going to put in a -1 for k. That doesn't always work, like I said and mentioned earlier. All right, so now my multiplicities and my zeros. Okay, so I have a 0 here at -1, so x equals -1. With a multiplicity, let's talk about the multiplicity of that. So the multiplicity is it's bouncing through the x-axis, so that means it has to have an even multiplicity. So let's try 2, all right? Now it looks like I have x equals 2 as my 0, and it looks like that passes right through the x-axis, so that has a multiplicity of 1. Okay, so now we want to know the y-intercept. So the y-intercept here is +4. Okay, so now in factored form, we are assuming, all right, we are assuming that p of x is equal to k times my factors x plus 1, because x equals to -1 as my 0, with a multiplicity of 2, and then x minus 2, and that factor only happens once. Okay, so now what we want to do is to make sure that this will have a y-intercept of 4. Okay, so in order to do that, I'm going to plug in a 0 for my x's. So this is 0 plus 1 all squared, and this is 0 minus 2. Okay, so 0 plus 1 is 1, and 1 squared is equivalent to 1. And then 0 minus 2 is -2. So this is +1 times -2 is -2k. All right. So on this side, we have on the right side, we have -2k. And on the left side, we have our y-intercept. So remember, this represents your y value, right? So when you plug in a 0, you should get 4. So 4 is equal to -2. So now when I divide by -2 both sides, again, you're noticing that k is equal to -2. All right, so that means that this isn't the final factored form. That means there's a -2 before. Okay, so the factored form is p of x is equal to -2, which represented your k, times the 0, the factors x plus 1 all squared, x plus 1 all squared, and then times x minus 2. So this is the polynomial that represents this graph that has a negative leading coefficient. It has an odd degree, okay, because by the time you multiply this by this, you're going to end up with a 3, which is an odd degree. And the zeros here are -1 and +2, so -1 and +2 checks out. -1 and +2. And then the multiplicity of -1 is 2, which bounces off the x-axis, and the multiplicity of x equals 2 only happens once. Okay, thank you for watching. Have a great day.